Maria is an advanced modeler and a domestic hot water researcher with California's Title 24 software, working with Redwood Energy. Prior to working with Redwood Energy, Maria was with the Integral Group, which is a really significant engineering firm, modeling large multifamily developments and commercial buildings. She's now with Redwood Energy, and she started here as an intern before she went to Integral. So she's back with us, and so she's a graduate of HSU's environmental engineering program. And one of the things that's interesting to note is that on our YouTube site, these presentations, like the one Maria's about to give on how to model with the software some of these advanced electrification strategies like central heat pump water heaters, this is what people want from our conference. Apparently on YouTube, we'll have like 600 views of these kinds of trainings versus, 60 or 100, etc. So for those of you out there, this is for you. Thank you, Maria.
Thank you, Sean. As Sean said, hi, Maria, and with Redwood Energy, and I will be presenting on modeling challenging and electrification products in Title 24 software. So just a presentation outline. I'm going to go through focuses of the presentation, then I'm going to introduce the project that I used for this presentation and the research task. Then I'm going to review some energy results and some modeling inputs. I'm then going to list a couple of updates that we made to the Redwood Energy, that's what RE stands for, models to simulate the building better. And then I'm going to show you how to model central domestic hot water heat pump water heater systems. And it is live because I'm going to do it during the presentation. And then I'm going to show you the new results and then some of our things that we learned, and be open for some questions. So one of the main focus in this presentation is how to model properly a central domestic hot water heat pump water heater system in Energy Pro A 2.2.0 version. I specify Energy 8.2.2.0 version because this version of Energy Pro allows you, has the features that allow you to properly model a central domestic hot water system. Some other focuses that I will be going through in this presentation is modeling a building with no natural gas and with gas available and how it changes the standard design. And some difficult, just discuss some modeling challenges such as like unmet load hours and how to get rid of that not complying margin due to unmet load hours. So Redwood Energy was asked to engage a mid-rise multifamily Title 24 model in all-electric jurisdiction of San Mateo County for an all-electric building that was not complying with 2019 code. The client, let's say, due to confidentiality, we're not going to give the name, so we're going to name Team A, the client, asked us to review 2 buildings in the project scope. Review the PRF reports that are generated by the software so that we can give them feedback and where they went, where they need to change, what they need to change to make their models comply. Now, for the purpose of this presentation, I'm only going to focus on 1 building. So again, we modeled an all-electric mid-rise multifamily building in Redwood City, Climate Zone 3. The building consists of 5 stories. The first floor includes non-residential spaces, such as a community space, offices, and a child care center. Floors 2 through 5 include residential units. The building also includes a central domestic hot water heat pump water heater system that serves the entire building. It also has heat pumps that are for space heating and space cooling and all electric appliances. So, as I mentioned, we took Team A's PRF reports and our PRF reports, which is the compliance report that's generated through the compliance software, and I put all the energy results into this beautiful graph. As you can see, it has the building energy breakdown. We have indoor lighting, domestic hot water, pumps, heat rejection, indoor fans, space cooling, and space heating. As I mentioned, that Team A's models were not complying. We can see that it's not complying by negative 1.6%. And a lot of it is due to the HVAC components, such as like space heating, space cooling, and the fans. And in terms, like for Redwood Energy, our building is very compliant. And you can see that domestic hot water is slightly higher than the standard design. And this, I will be discussing as to why in the next few slides. So first, we have the space heating. You can see that the standard design for both the Team A and Redwood Energy's standard design has a slight different energy TDV. And this can be due to the fuel type. The Team A had set their models to natural gas available in their building. This is shown in the report, whereas we do not have that in our models. So that can be one of the reasons as to why the standard design is slightly different. The heating energy for the proposed design for Team A and Redwood Energies are very similar and slightly different, and that can be due to HVAC efficiencies. For space cooling, again, their Team A and Redwood Energy standard design is a lot different. Again, we're not quite sure as to why, but one can be that the standard design is different because of the natural gas available in the building. And then we also, in the proposed cooling energy between Team A and Redwood Energy are different and are due to because HVAC efficiencies are and differences in glazing values, and that can affect the spacing and the space cooling energy. In terms of domestic hot water, as you can see that this is a huge energy portion of the total building energy breakdown. For Team A, they did not include their domestic hot water system. And part of the reason why I think that they might have not included it was because, well, as it is, the building's not compliant, but it probably, it doesn't model, so earlier versions of Energy Pro doesn't have the capability of modeling properly a central domestic hot water system. And you can see that even though it has a value of 16.5 and 16.5, they cancel out. So, and it shows in the reports. Whereas Redwood Energy did include their domestic hot water system, and you can see that it's complying slightly worse than the standard design.
And it's just to note that we do have a larger allowance in our standard design, which I think is also because of the gas not available setting.
Yes.
Yeah.
It changes your baseline system. Fan energy, we have, again, there's a huge difference between the standard design and the standard for Team A and Redwood Energies. This again can be through the change in the natural gas available, but also the SEER values that incorporate the fan efficiency. And that's something I learned recently. So thank you, Sean. Also, the proposed design fan energy for Redwood Energy is much lower than Team A, and that can be due to the HVAC efficiencies. Last but not least, we have the lighting. This wasn't really hard to figure out because Team A incorporated their lighting fixtures into their model, whereas Redwood Energy used the default prescriptive LPD values, and that's where you can see that in the Redwood Energy standard design and the proposed has both the same 3.27. And so now that we went through all the results and a couple of reasons as to why they are different, we decided to update the models and run a second round of models. And one of the big changes that we did is I redid the domestic hot water system and uploaded the models into the new version of Energy Pro 8.2.2.0 to model the central domestic hot water system properly. We also, another thing that Team A was coming across was unmet load hours. So even though one of the buildings was complying, the proposed design was better than the standard, it still was not passing due to the excessive unmet load hours. And that's one of the things that, unmet load hours can be due to either not enough heating capacity or cooling capacity, or CFMs. But in this case, there is a switch in Energy Pro that will allow you to get rid of that not complying margin, and but it will still show up in the report, the zones that need that have unmet hours and that need to be fixed. A couple of minor changes that I also did in the models were envelope updates, such as floor construction, zone assignments to correct HVAC zone systems and based on HVAC zoning, and added some missing spaces. So as I mentioned, one of the really cool things that I found in Energy Pro, that there is this switch that you can click so that you can get rid of the unmet load hours, but it would the spaces that have unmet load hours would still show up in the report, but it will still comply. If you go to the zone level under the mechanical tab, there is this add cooling. As you can see on the right side, it's highlighted in blue. And basically that would add cooling to the background to meet the unmet cooling hours and will not affect the reporting. So finally, to the good stuff. I'm going to show you how to model a central domestic hot water system. But before, I'm going to talk about what the system is. So it's in, it has 8 compressors of Comex CXV-5, 2 storage tanks of 1,080 gallon, 1 electric resistance system for the recirculation loop with storage tank of 175 gallon, and a recirc loop that includes demand control. So let's get to this real nice. Okay, so here is Energy Pro 8.2.2.0. If you've never seen Energy Pro, this is the software. Under the building, you create your central water heater, and then under the domestic hot water tab, click on this tab, and then you have this whole section here. Prior to this version, it only used to be this above, and you would model your system here. Now you have this multi-family central system, heat pump water heating system, and so on. In this, for this building, since it's the first floor is consists of non-residential spaces, and floors 2 through 5 are residential spaces, you have to model the spaces separately. So non-res have to be separate, modeled separately from the residential spaces. So all the non-res spaces are modeled in a separate water heater that would go here, and the rest would be modeled down here. So you would have selected multi-family central system, and it's a heat pump water heater system. Then you would select the type of pump control you have, the power. Then right here, since we have Colmec, you can select from the NEA rating heat pumps, and the number of heat pump count. So you include all your information in here, and you can select whether if the tank is inside or outside, and the recirc loop as well. Now, it is important to know how much of the load is going to the non-res spaces, so that you're able to know how big of a system you should build for your non-res spaces. So if you know that, that's awesome. In this case, we kind of had to estimate. So going back to our presentation. Now that we modeled the new, made the updates, and I modeled, these are my new energy results. And as you can see, It is now passing by 12%. Originally, it was passing by like 1.7%. You can see that the domestic hot water energy reduced by a lot, and almost every energy use is lower than the standard design, except for like space heating, and that can be due to that unmet heating load hours. So some of our findings and some of the things that we found important to give to our client, Team A. One is modeling the building with the no natural gas available rather than natural gas available. This was supported by the CEC, PG&E, and the San Mateo County policy. Also, compliance required increasing the HVC system size due to unmet load hours, and modeling the domestic hot water system for compliance rather than taking the prescriptive compliance path. Again, if using the Energy Pro version 2.2.0 has features to model a central domestic hot water system. Any questions?
Woo! Yes, I do. Could you go back to your open software and
Yes.
show us the central domestic hot water?
Yes.
Thank you. Jenny Kuna says, "Go Maria!" And Jim Lutz would like to talk more about the unmet cooling switch, just so you know. But
Yes.
the question I had here was, as you review this, do the plumbing and mechanical plan sets, the sheets, do they give you this information? For instance, the loop count, the insulation thickness, the pump multipliers, the design power, like the 0.5 heat pump.
Okay.
And I'm sure that some of this, but I'm wondering about your experience. And I realize that we're all just exploring this software for the first time, but do you think
Yes.
you have what you need?
For the most part, I would say like 80% of it, it's included in the MEP plans. Sometimes the insulation thickness is not included. Loop count, I mean, it would just be, I guess you would have to like look through all the plumbing floor plans. But for the most part, it is included. Sometimes efficiencies are the ones that we need to ask for cut sheets, like the Comac. I had to look for the Comac CX V5, even though this already includes, it's incorporated in here. But for like the Rain, you kind of do have to ask or request for the cut sheets to get more specifications of the system.
That's interesting. The solar savings fraction, that was new, right? I don't think we've even played with that since, like we talked about earlier, incorporating hot water into the supply to a heat pump isn't a good idea.
Oh yeah. So yeah, I have not explored that yet. It'll be maybe another research thing to do. Yeah. Yeah, I have not played with this yet.
Well, I really appreciate this. I mean, I on personal was like, okay, I'm learning a lot here. I needed to understand how does this software work better, since this is brand new to all of us. Any other questions over on this side? Jim, I know you're there, so I'm wondering, are there any questions you had for Maria on the software as you see it? Maybe played a role in helping make it. If not, what's that?
Are the questions on the chat?
Well, yeah, Jim had also commented, isn't the unmet cooling switch cheating? Shouldn't it increase the proposed design load?
It doesn't do anything to the, what it does, it just changes the, so let's say, for example, in one of our buildings, the entire proposed design was compliant with, so all the, space heating, space cooling, domestic hot water, fans, all of it was, the proposed design was much better than the standard design. But for some reason, there was unmet heating load hours or cooling in one space. and it wasn't passing just for that reason. So what it does is it still puts that zone in the report, that this zone is not, it has excessive unmet load hours, so that you know that this needs to be, we need to go back and fix it. But it does take away that not complying margin, I guess that's what, yeah.
So you can get a building permit even though the system has
Yes.
unmet load hours.
That's what I was saying, but it still means that you still need to go back and fix it. Yeah.
Or, you know, sometimes engineers deliberately undercool areas. I've just heard an engineer speaking on that a couple of days ago, where they decided to like take in night cooling, which might not be modelable, or other, like they'll do their off-sheet calculations outside of the software and feel like they can defend their analysis. And so they got a stamp, and so they get to kind of say that. And then the software perhaps allows that to happen.
Yeah.
Okay. The one other thing to bring up. So if you could go to the initial slide of the difference between one modeler and another. So
Okay.
team A versus, right? Yes, thank you. So one of the things that wasn't mentioned is that the team A design had actually sort of disappeared some of the floors. And that had meant to a reduced, functionally like a reduced amount of space, which would then had the reduced standard design. And that was subtle. It was not easy, you know, we picked it up, but it was an example of how, and we've also seen this in other ways. You can do settings within the software that are important, but are not visible in the printouts and cannot be plan checked, even though they're important. And this is an example of that, where you can disappear square footage and have it be difficult to note, and have it then change the whole model of what's important to do. You know, if you have a different amount of TDV energy allocated to HVAC because you've disappeared square footages, then the domestic hot water system might look more significant than it actually is, etc. So I want to make an appeal to the people who are hearing this to note that we could do a better job of transparency in our printouts and in plan checking, so that the code actually gets implemented by the CEAs, because these two graphs, you know, looking at Team A versus Redwood Energy, they're different in important ways. Some of which are minor, but like look at the fan energy, just huge. Look at the red domestic hot water. These are massive differences with real world design impacts. So as our software evolves, I think it's important that our printouts evolve. Like that domestic hot water loop there, I don't know if have you printed out your PRF-01 form, Maria, so that we could say like, what does that really do?
I have not. Well, I do have it printed, but I don't have it open right now with me.
It's okay. I'm just saying, like, I'm not sure if all that information you have to enter in is printed out and therefore can be plan checked.
Yeah, so every component does show up in the PRF report.
Oh, good. Okay.